So today we're going to talk about the graphs of sine and cosine. And so I have the unit circle up here first, just for us to take a look at. So I thought the first thing that we would do is graph sine. So I brought the unit circle up here just so that we can kind of look at things here. And so if you look at 0, right, my sine I'm going to graph first, then I'm going to have 0 because my y-coordinate is 0. So at pi over 6, I'll have a half. So these are like ordered pairs. I'll have 0, 0, pi over 6, a half, pi over 4, square root of 2 over 2, which is the same as 1 over root 2, square root of 3, square root of 3 over 2, pi over 2, 1, 2 pi over 3, square root of 3 over 2, and so on, all the way around. So basically, all of these radian values match up with the y-coordinate here. Okay, so we're going to look at this. So essentially what's going to happen is this is kind of like my graph generator here. And so I have this set up. So it's following the y here. It's going to follow it around and see what happens. Let me close this up. So and now I'm going backwards, so that's the negative part of my graph. Let me slow this down. I don't like that. Oops. Going way too fast here. Let's slow it down. Okay. Now let's take a look at it. Okay, so as my graph is going around, it's tracing out, right? So just going around in the circle, this is not a function, but this is the sine value that's taking all the y values here and then coordinating them. So at 0, it's 0. This spot up here, at 1, this is probably pi over 2, 1, right? At here, I'm going to end up at pi 0 because sine of pi is 0. So when it comes back around, sine of 2 pi is also 0. And so essentially this is tracing out the sine function. Right? So let's go to a different graph here. All right, so y equals the sine of x looks like this, right? Where I have the point here, pi over 2, 1. So this is just the big ones, right? So there's 0, 0. At pi over 2, I'm at the top of my unit circle, so that's at the point 0, 1, which means sine is 1. Then here at pi, I'm back over to the left side where sine is 0. Then I go down to 3 pi over 2, which is straight down, negative 1. And so this graph is oscillating, okay, is what we say. So this is basically it looks like waves, right? So this is a way to represent something that is coming, that kind of goes in and comes back out and goes in and comes back out. So there's some new vocabulary that goes with these, and one of those is the period, okay? So the period of any trig function is basically how long it takes to make one complete graph. And if you think about the full unit circle to go all the way around, that's 2 pi. And so it takes us, here I go up, right? If I start at 0, I go up, I come back down to pi, and then I go negative, and then I come back up. So now if I start right here, then I'm in this exact same place with this point as this point. And this is exactly, again, the same thing, right, until I get here. And so the period of a sine function is, in fact, 2 pi. So now, sine and cosine are very similar. Let me take off sine here, and we'll put on cosine. The difference between sine and cosine is that the cosine of 0 is 1. So this one, instead of sine, if I put this back on here for just 1 second, sine is actually starts at 0, 0 here, right? Where cosine of 0 is 1, so it starts up here. But then it travels through all of these other ones. So cosine of x looks just like this. And so for it to complete a full cycle through everything, it starts here at 0, 0, right? Then I'm going to go down. And then basically this is my new starting point, right? This is the same place as here. And then it goes down, and here's another period. And so the period for sine and cosine are both 2 pi. Now really, if you think about it here, look at these two. These are just a phase shift of the same graph. Now a phase shift is what in trig is what we just call basically a shift. So this sine and cosine basically differ by a shift of pi over 2. So if I think of this, let's see what happens when I do this. Minus pi over 2. So basically, sine and cosine are exactly the same thing. It's just that one of them is shifted pi over 2. So if you notice, right, this is just like all of the other graphs that we've talked about. When I put the x minus something in here, that means it's shifted pi over 2 to the right. So the sine graph is really the cosine graph just shifted pi over 2 to the right. Okay, so let's take that back and we'll go back to regular cosine. Oops, let's take away sine now. Okay, so they both have the same period. So another thing that we talk about here as another new term is the amplitude, okay? So now amplitude is actually A. We're going to add a slider here. So in our particular case that we're dealing with right now, our A is 1, okay? So it says A is 1, so what I'm going to do is play this. So amplitude, the A stands for amplitude, it goes out front, and what it does is basically it changes the height, right? It's kind of like springs. It kind of goes up and comes back down. So as my A gets very positive, my graph just keeps getting like a steeper roller coaster here. And when A goes negative, then essentially my graph flips over, right? You notice that kind of happens really quickly here. If I go to 0 here, then my graph kind of rolls over. But the amplitude is still the 2. Now, one way to figure out amplitude, I mean, if it's sitting here and it's right, it's not shifted up or down, it's fairly easy to see what the amplitude is, right? It's basically the 0 is right in the center here, like the x-axis, and basically this is 2 steps up and 2 steps down, so my amplitude would be 2. Now, if I shifted this graph up, it's a little bit harder to maybe see that necessarily. So another way to figure out your amplitude is basically to figure out the low point and the high point, and then you think, okay, well then this is 1, 2, 3, 4 steps up to get to this one. I divide that in half, and that would be my amplitude, okay? So now you might notice that when I add the +4, it shifts me up, just like the other graphs that we've talked about that were non-trig. Okay, so let's take this one off. Another graph that we're going to talk about is y equals the tangent of x. Ooh, now that's interesting, right? Okay, so what happens with this one is you will recall, I hope, that tangent of x is built from sine divided by cosine. And cosine of 0, or cosine is 0, right? We're not allowed to have 0 in the denominator. So if tangent is sine over cosine, then anytime that cosine is 0, I get a vertical asymptote, okay? So my cosine is 0 at pi over 2 and negative pi over 2. So if we kind of look, let me put in the, it's kind of hard to tell with these. But if I put in an x equals, I'm going to put in pi over 2, then you're going to be able to see that I'm going to have essentially, this is going to be this is a vertical asymptote here at y equals pi over 2, and on this side, there's another one that is negative pi over 2, because that one would also, is when cosine is 0. Oops, I did it the same thing again. Let me put a negative sign in front here. And so I get these two vertical asymptotes. Okay? And so tangent has these vertical asymptotes built into it because of the division. So all of the graphs of cotangent and secant and cosecant and cotangent, they all have vertical asymptotes in there because they're built from dividing trig functions. So since cosecant is 1 over sine, anytime that sine is 0, cosecant is going to have a vertical asymptote, right? So this is the graph of tangent, okay? So the tangent of 0 is sine over cosine, so sine would be 0 in that case, and cosine would be 1, so that gives me the 0 place here. And I know that at, let's see, at pi over 2, tangent is undefined because that would mean it's sine over cosine, and cosine is 0, so that gives me this vertical asymptote. At pi over 4, I get this point right here, where actually, no, I don't. I'm looking at the wrong thing, but it's approximately right in here somewhere, because pi over 4, we know, we've kind of looked at it before, the tangent is 1, so pi over 4 is somewhere right in here. I can almost click on it, but not quite. So if you decimal approximate pi over 4, you can kind of see the decimal. But this is basically the graphs of sine, cosine, and tangent. So the period on cosine and sine to make a complete graph is 2 pi. Tangent is just pi. Okay, so basically it goes, because this just keeps repeating, and since this is negative pi over 2 and this is pi over 2, then basically the whole length of this is just pi over 2. So, or is pi, I'm sorry, because it's each from 0 to here, and then from 0 to here is pi over 2. So I have pi over 2 plus pi over 2, which is just pi is my, it only takes one, it only goes from 0 to pi is what it takes to make a complete graph of tangent. And that goes with cotangent as well. Now let's look at a couple of other graphs here. We'll take these off. And we can just kind of take a look at y equals the, I'll say secant of x. Oops. This one's kind of interesting, right? All right, let me take tangent off of here because that's confusing. So this is secant. And what's interesting now, secant, it also only takes, because again, secant is made out of cosine. So cosine, if I put these back in, actually these apply for this. So cosine is 0 at pi over 2 and negative pi over 2. So these have the same vertical asymptotes as tangent because they both have cosine in the denominator. And you'll notice that something very interesting happens when I put in cosine here because it's built from 1 over cosine. So when I plug in cosine here, oops, let's take away this a. So this is regular cosine here. So you notice, I thought this was kind of interesting, that essentially these little parabolas, they kind of look like y equals x squared, right? These little parabolas, they happen at the top and the bottom peaks of my cosine graph. And the same thing happens with secant, or cosecant and sine. So let me take these two off. And we'll put on sine instead. Actually, I won't leave this on here for a second. We'll put in sine and then I'll put in cosecant. So y equals the cosecant of x. This one looks very much just like the other one, right, that we just looked at with secant. It's just that they're shifted. Oops, that's not what I meant to click on. How about here? Okay, so essentially they're the same graph. It's just a shift again. So if I take off secant, there's cosecant, and the same thing will happen with sine. You notice that my cosecant graph and my sine, they're reciprocals of each other. This is what happens, okay? So every time, essentially, this hits my, my actual sine graph hits 0, I get a vertical asymptote there, okay? So essentially, it's here, it's here, it's here, and you notice that kind of if I think of it going straight down here, it'll be straight down there, okay? So what I want you to do, and this is sort of your in class, this is what I want you to, this is kind of an entry problem, is I want you to think about, and you can just do this, let's just start with sine and cosine. What I want you to do is put in y equals a, and then sine of bx minus c, and parentheses, plus d, and then you click all on the slider, and there's a lot of stuff going on here right now. But what I want you to do is move each one of these individually. Now we already talked about A is the amplitude, so you already know what A is. It changes the height of my curve essentially. But I want you to play with B, C, and D and just tell me in like one sentence each what you think B, C, and D do. And it works the same way for cosine, so if you want to look at cosine as well, you can do that. And I will see you in class.